Okay, let's look at what this problem says. A circuit with a current I has two long parallel wire sections that carry currents in the opposite direction. Find the magnetic field at point P near these wires, that is a distance A from one wire and B from another wire. Okay, so what we're doing is we're finding the magnetic field at this point. Okay, yeah, so here's a current coming out of the paper. So if you stick your thumb out in the direction of the current, your fingers will tell you that this current will, we'll actually call this 1 and this 2. Due to current 1 is in this direction, so that's the magnetic field perpendicular to A, and the field due to current 2, again you stick your uh, thumb in the direction of the current, and the field due to current 2 is in that direction. Okay, find the magnetic field at point B, at P. Okay, so now it's a matter of adding those two vectors. Okay, all right, so let's do this. The magnitude B1 is mu naught I, the currents are the same, 2 pi A. The magnitude B2 is mu naught I, 2 pi B. Okay, and now we'll have to use vector notation to write the components. Okay, let's call this angle theta, and so B1 is so this angle is theta, and you can figure out that this angle is theta as well. Okay, so B1x is okay, B1x I plus B1y j. B1 is B1 x is minus sine theta, okay, plus B1y is B1 cosine theta, B1 cosine theta j. Okay, so B1 is, and sine theta you can see from the diagram is B1 B over A I plus, and cosine theta is this side is square root of A square minus B square. B1 A square minus B square over A j. So there's B1 in terms of its components. Similarly, B2, B2 is a lot easier, is just it just has an x component. Okay, so the net field at P is just B1 plus B2. Okay, so let's add a sheet before we calculate that. So the net field is minus B1 B over A I plus B1 A square minus B square over A j plus B2I. Okay, so this is equal to B2 minus B1 B over A I plus B1. Okay, so let's clean this up. Here are B1 and B2. Okay, so we'll put those values in. Okay, so B2 is mu naught I 2 pi over B, mu naught I 2 pi over A, B over A, I plus okay, now it's just a little algebra to simplify all of this. So what we'll do is we'll pull out mu naught I, the common factor. So mu naught I, mu naught I 2 pi. And the first term is 1 over B minus B over A square I plus square root of A square minus B square over A square J. Okay. And so we can simplify this further. Okay, we'll do this. We'll pull A square common. I guess we'll just pull A common. What I want to write this as is, okay, yeah, we'll do A. Pulled out an A, so this is A by B minus B by A I plus A square minus B square over A J. Okay, now these guys are dimensionless quantities. See, this is length over length, and this is length square, square root of length squared, so length over length. Okay, so we've expressed the magnetic field in terms of the field due to just the wire I times this vector. Okay, so there's the magnitude of the field at point P due, so we have expressed it all in terms of that magnitude. Okay, is that what the problem was asking? Find the magnetic field at point P. Okay, so that was what was asked, and there's the magnetic field. Okay, that covers that problem. So let's end this.